Hi, everyone. Welcome back to another episode of Unscripted Coding. Today, we're going to be putting two different projects together to make a better, bigger project, I suppose. The very first project we did that's relevant to this is our computer fan. So I have here a spinning computer fan, and all we did in that particular project was connect it to the wall. How do we deal with all of these wires, connect them to a wall socket, and just get them running independently. The other video we did was a quick comparison of a couple of, two remote controllers for Arduinos. And this one uses an IR LED at the top to convey commands. So we'll be using one of these remotes to control an Arduino. Now, both of these projects, I'll have the link in the description so you can see, part 1, part 2, and finally this video, which will be part 3 of Unscripted Coding. Now, where do we want to go first? What is it we're trying to do? Well, what we're trying to do is find a way to take this remote and basically be able to turn on and off these computer fans. And so if, say, I point at it and click, let's say, a 5, hopefully it'll turn it up or down in speed or turn it on and off. To do this, we're going to need an Arduino, and we have one right here. What I want to do really quickly is just transfer this over. Okay. Where are my wires? It's extra ones. Perfect. I'm gonna transfer this over onto a breadboard. So this is a breadboard. It has a bunch of pins for you to connect wires together. And in our last video, we took pin 7. You know what? I better do this properly. Ground, VCC, and pin 7. Okay. Just gonna put that right on the edge there. We had pin. And I'm just connecting the receiver to the breadboard. So pin 7 was this left one. The middle one is positive, so that should go to VCC. And finally, the last one goes to ground, which is white wire. Okay, so you might be thinking, what now? The main problem here is I want this Arduino to be also powered by the same 12-volt supply here. So I am going to get some more red and yellow wire. But the problem is this power supply is 12 volts. And if you connect 12 volts to Pro Micro, you might fry the chip. And so we have an IC regulator here. This will bring down the 12 volts to 5 volts. And so 12 volts go towards these fans. And then on that same line, we break it off to another power into the Arduino. And because it's 12 volts, we're going to stick this in between. And so it outputs a clean 5 volt to the Arduino. And so it has a nice, stable, maintainable power. So let's do that first. Step one is how do we connect both of them together? And I am using this voltage regulator called the LM7805. Now, I'm probably not doing it properly. I'm going to be doing something similar to this image right here. Let's go with this one. It's a better image. If you're doing this properly, you should be using these capacitors right here. So you should have a capacitor controlling the power coming in and another capacitor on the power going out. I don't have capacitors, but the whole point of the capacitor is to try and stabilize the power so that the regulator gets clean inputs and outputs. I think we can do without, but again, good practice. You should probably do things properly, especially when it comes to power. Okay, so I am going to grab some more yellow and red wire, or over here. Okay. Red, yellow. Okay. I am just leaving these kind of exposed on the side here. And you can watch my table right here, further back. Red, I think, is positive, and then yellow is negative. If I put this to ground, okay, and put the 12 volt to the raw input, you're going to see the Arduino blink red. And you can see that. You don't want to do this often. The Arduino Pro Micro has this raw input. It has a built-in regulator. So if you do put 12 volts through, it will accept and it will run what needs to be run. But the real problem here is that, how do I say it? The real problem is that it's going to burn. The regulator on board heats up, and there's no heat sink. It's not exposed. It's not designed for sustained 12 volts. So what's going to happen is the Pro Micro is going to get hotter and hotter and hotter and then burn itself out. So I wouldn't recommend doing it, although that's a possibility if you need it for a short, I'd say 5 minutes, probably even less than that. You can plug it in directly to the wall and you get the red LED. Okay. So what we need to do is plug these into the power rails. And I realize you're not going to see very much of this on screen, but I don't think it helps zooming in. The wiring is going to be quite messy. All I'm doing is recreating this particular image. Instead of a 9-volt battery, I am purely putting this into the wall, which is a 12-volt. Now, in this image, they are using a Arduino Nano. So what I said was raw is actually labeled as VIN in this breadboard. So if you were going straight from the 9-volt to the Nano, you can connect ground to ground, but VIN to this 9-volt battery. The whole point here is to connect the battery, go through the regulator, and then connect it to the 5-volt input. Okay, so Let me see how that looks. Okay, this is the IC regulator. Just as fun kind of thing, this is the first time I've played around with one of these, so you're probably going to see me make a mistake. All of the images show this black square, and then the top part is metal. Just let me flip it to the other side. So you can see the backside is the metal extends all the way down. It's just, yeah, that way you can kind of know that image, the front is very obvious. So when I was buying this online, I was trying to figure out, well, where is the front? Okay, I am just going to take a spot way down. Go. Okay. So ground will be the center. Let's move this down. Okay. Ground is the center pin, so I'm connecting that first. That's this black wire down to the center pin of the regulator. The red pin, power from the wall, should go to the left pin. So I am going to put this into the left pin. And I need more red and yellow cables.
This came back from a search.
Stop.
Counting table near you.
My voice assistant is activating, so turn that off. Oh, and in case you can't tell, it is starting to get hot where I am, which is why I need these fans. Okay, so I'm going to keep going. Ground connected to the ground of the Arduino. And then power from the right pin of the regulator. That's over here, this pin. Finally, that one connects to, I think VCC would do it. Okay. And there you have it. I just plug and unplug this. You can see the very slight blink of the LED. So all I did was wire this up. I still have the sensor from our remote control. So in theory, if I had this plugged into a serial monitor, it should be detecting when I click 1, 2, 3, 4, 5, 6 on the remote. So we have that running. I should. Yeah. I should connect the fan back on so I have a fan pointing at. Negative to negative, positive to positive. Good. Let's have these fans pointing at me. Let's give me a bit of wind here. Okay. So what else do I have? I have one more cable here. From the fans that's exposed. What am I doing with this one? And again, I know you can't really see all that well. What I want to do is be able to control the fan. Federico Docena has this fantastic resource on how you can control fans with the Arduino. I will link this in my description as well. And essentially, these fans are PWM fans, meaning they're pulse width pulse width module fans, which means that they are, when you send pulses through the Arduino, through this wire, through the very last pin of the cable, you can control the speed of the fan. If you pulse very slowly, then the fans will slow down. If you pulse very high, it's still, it's not running off the Arduino's power, it's running off its own power, but the pulse tells it how fast to go. And so in this case, I have already done a quick test here. And this is what I've done. Pin, I've adapted from their site, so you can copy it straight from Federico Docena's website. But there is all of this tricky thing to give the pins on the Arduino the right frequency that the fans will recognize. All of this is setting up what's important. And then over here, we have different pins. I think this is irrelevant, but we're going to be using pin 9 to send these pulses off. And so in theory, in fact, it doesn't have to be in theory if I just connect it now. See, one of the problems about this workspace is once you have too many cables, you don't know what's happening. Okay, so I am going to upload the sketch, this one. And upload it. Very good. And the moment it did, what happened was pin 9 has the set PWM 1A, and I've set it to not 50%, but it's running test, 30% because it's 0.3 floating. It can range from 0 to 1, and that's just how Federico has set this function up. Basically, changing the pulse based on these timers. I'm not going to claim I know exactly what's happening with the math here, but essentially he's scaling it from 0 to 1 for our convenience, and then we can set it to 0.3. So the fan is running quite slow, I guess 30%, and then if I pull this pin out, I hear it speeding up, and you probably don't hear a thing, but it is much faster. And so all I'm showing you is that I can, as soon as I connect to a pin, it's getting those pulses out, and therefore it's slowing down the fan. Now we can combine this with our other code that we did on the remotes. And so let's step back for a second. All we've done is a setup, and this set PWM1A, I'm going to remove this and this to be less confusing. Federico had 3 different pins going at once. All we care about is the one pin because all of our fans are daisy chained into one output. What I wanted to say is that this is all done in the setup. In theory, we can move this into the loop and we can combine it with the code we did for our remotes. And so we can control it so that if I receive a different value from 1 to 0, instead of just serial printing something, I will set the fan to different rates. Okay. Now let's copy these over. This will be right up top. Let's keep this in front of the pins. And finally, we have this. Okay, so I am going to set it at 1.0. And if I select a 1, I'm going to set it all the way down to 0.3. Save this, upload it. Fan's going real slow right now. Now that's done uploading, fans are speeding up. That's because we set it to 1.0, so it's going at 100%. And hopefully, if I've done this right, I can click 1, and it's going to slow down. 1. And yep, it slows down. It's all the way down. And so all we've done is combine both of these together, and we're just detecting what the value is and setting it differently. Now, if you don't mind, I am going to just record down really quickly other numbers. So 2, I have a whole bunch of buttons, so I should be able to go 10%, 20%, 30%, however many percent I want on the fan. 5, 4, 5, that is 2. And then let's go with 3. Negative 7651. 4 is 8925. All right, I'm just going to work with 4 buttons for now. But and I know this video is running a bit long, but I desperately wanted one other feature. Now, it's slowed down to almost a halt at 30%. I suppose I can go even lower to 0.1. I have tried 0.0 in a test before this video, and I find that the fans are still technically spinning, albeit very, very slowly. That's because power is still going through. What I have here is a Mosfet. I don't know if that's how you pronounce it, but that's how I read it. It's the IRL 530 Mosfet. Now let me pull up what this is. Okay. Nope. Okay, so a Mosfet looks like this, and you'll notice that it looks almost identical to the IC regulator. So I made sure to keep them in the right bags because they're hard to tell the difference. What is a Mosfet? Well, you have a gate, a drain, and a source. Now I'm going to show you this picture. The whole idea here is you want to be able to shut off power to another device. And this is super useful for Arduinos because even with this IC regulator, and it's getting slightly hot here, even with an IC regulator, that's good. So, okay, even with an IC regulator, this is not the best way to do things because you can never actually control the power going through these fans. And you can think of all sorts of additional features, additional modules you might want. One example is if you have a giant motor, let's say one as big as my head. Okay, that's going to take a lot of power to run, and you're going to have to find a way to connect it to the same power as the Arduino. You're going to output a lot of heat. You're going to do all sorts of crazy things to get it working. But you will never have that option of having the Arduino siphon power because all it has is 5 watts. You're not going to power a giant motor with an Arduino. And I remember when I was learning how to play with these Arduinos, we had to use our imaginations a little bit. We had a bunch of blinking LEDs, and my teacher was telling me, well, just picture this as a giant motor. You're doing the exact same thing. You're just putting power into it, turning it on and off. Yes, the LED is blinking, but use your imagination because the same logic will drive a giant motor. The problem is the power. LED is powered straight through the Arduino, but your motor is going to be powered through the wall, through a giant battery, some way else. Okay? The Mosfet is one solution. Another one is a relay, power relay. Okay, a power relay looks, I guess, like these. Something like this is what I'm imagining. You connect the wires in, and then basically as soon as you send a signal to the relay, it just shuts off the power. It is a complex piece of, it's not super complex, but it's more complex than one of these IC chips. And they're pricey. They're like $10, $15, but you connect, you power it through, you wire your wall socket into it, and then it outputs power to, say, your giant motor. And then you have a pin connecting somewhere else over here that as soon as you send a signal through the Arduino, the relay will shut off the power. That's one possibility. Another one is a MOSFET. MOSFET is cheaper, and there are limitations. You wouldn't be able to do this with, I don't know, 50 watts or even much higher than 12 volts. Sorry, 50 volts, 12 volts. And what it does is exactly the same thing. You input a signal into one of these pins, and you keep it on, and it will shut it off. And then you take that power off, you shut off the pin, you stop putting power into it, and it'll let the power flow through again. So it operates very similar to a relay, but all it's doing is letting the power drain out. It's not cutting the connection like a power relay. And as a result, you have the same shape because it gets hot as well. Yeah. It gets hot as well, and then this little metal part is basically a tiny heat sink. Whereas a relay shuts off power. If you have a bigger budget, the relay is probably the much better solution. But I'm gonna put this one here, and we're gonna start rewiring the power. Okay. All right, how do we do this? I've never actually used one of these, so I am trying to convince myself how we're going to use this. Okay, so why have they wired it this way? This left side is going towards ground. You know what? Let's take a look at one of these. So this is the power source. They're connecting to the middle. Okay, that's pretty terrible. Let's look at this one instead. 1, 2, and 3. Okay, change of plans. I'm gonna stop talking for a moment, and then we'll come back when I figure out how to actually use this Mosfet. Okay, and we're back. So I've connected the Mosfet. We can turn these off. Basically according to this image, and let's see if according to this image is probably the best one. The very right pin goes to ground, okay? So Arduino connects to ground, this thing connects to ground, you can have them separate, it doesn't matter. This connects to the ground part of your power source. The leftmost pin connects to something on your Arduino. I've connected it to pin 8. And so this is where you can turn it on and off. And finally, the center one, this is the drain, connects to the ground of your motor, or in our case, the fan. And the whole idea here is it's going to switch out. When you connect power through this MOSFET, it's going to cut off the ground. It's going to disconnect the circuit for your fan, your motor, and then when you power it, it's going to complete the circuit for you. It's really doing this through resistance, so it's not like a relay where it's physically cut. This is just dealing with the resistance in between the circuits. And so the best way to understand it is your motor has its own independent connection to the negative that's going through this MOSFET, and it gets cut off when the Arduino wants it to. Really important thing is it did take me quite a while to find the right MOSFET. Not all of them work. What you want is something called a logic level MOSFET. And there's a ton of different ones, but the main point is, say, look at this one, IRFZ. If there's no L in the name, chances are it's not a logic level MOSFET. And what that means is it's going to take a lot of electricity, like you need 12 volts, 20 volts, or something to cut off that power. The logic level, you can do it in 5 volts, meaning that even that tiny bit of electricity from the Arduino is enough to cut off power. Now, let's go back to our code. What I've done here is I've set a new pin. 8 is the one we've connected our MOSFET to, and then we did a digital write high. Right when we turn it on, when we reset it, the fan is on full power. It's high, so power is going through these fans, and then we've set it to 1.0, which is 100% on the fan. We are doing a loop constantly, and we're just picking results. When this detector, and again, I realize you don't see everything. Let's do a monitor here. When it detects anything, it's going to do this whole print what the code is, get what the value is, start searching for the next one. But if I click 1 on my remote, it's going to have the power of the fan. So let's click 1. There we go. 1, and then it detects it's a 1, and then the fan is half the speed. And then if I click 3, and I mistakenly thought this was 2, monitor out again, click 3, we'll get this as 3, and I can see my fans just slowing down. Just gonna stop them manually. And this is not working as I thought it would. And then when I click a 3, there we go, the fan stops working. It slows down to a halt, and I notice that it does turn on and off a little bit. So you can see this fan is just not moving. You can see the individual blades. This one, however, is just slowly moving a little bit, and then it stopped. And the whole idea here is the Mosfet is not perfect. It's going to slow it down drastically. It's going to slow it down, and then it's going to let some electricity flow. Like it's going to complete the connection a little bit. It's going to let the ground connect every now and then you see kind of drips and drabs, and you can see the fans coming up again. And I think the most effective way to do this is actually to set the speed down to 0 as well. So not only is the fan being told to go as slow as possible, it's also getting very little electricity combined together. Effectively, you have a fan that will barely spin at all. And that completes it. This is a really simple circuit. It's using a Mosfet. It's using a IC regulator. And why this is really important is because there are so many applications for Arduinos where you want to power something much more than an LED. An LED, the 5 volts is fine, it'll glow, whatever. But if you want to do a motor, if you want to start probably not a car, but if you want to do a robot, if you want to do some sort of machinery, you need to learn how to deal with these, and this is a really good exercise. 12 volts is not a whole lot. You get these kind of very cheap parts. So together, the Mosfet and the IC regulator was like $3 for me, and I think I overpaid for them. And with these parts, let's see, $3 remote, $3 Mosfet and IC regulator, that's $6. The Pro Micro is probably another $5, $11. Let's say another $1 for the wires. It's $12 to get something working. To have all of your electronic parts. And then of course you need the fans. You need the giant motors. Big motors can be very expensive, but you can get a pretty powerful one for like $30-$40. And then these DC adapters, they're super generic, so you can get them for $2-3 most of the time. And at, let's say, $40, you can have a really powerful, say, arm. A motor that runs an arm forward or back. And it all comes down to just understanding what parts you need. And I feel like this is something I didn't get when I was learning to play with these. How do you scale up? How do you go beyond the LEDs? How do you go beyond the really basic stuff? And so I am super happy with this. Let me just turn the fan off here. And yes, I think it's still kind of going. I think I might invest in a relay in the future, but I think the same code basically works. You're just sending a digital write onto the relay. You gotta figure out the wiring a bit, but you can tack together all of these images that we were looking at. Which one was the helpful one? No. Well, what I want to say is, this one's a helpful one. You can tack together these diagrams, and you can combine multiple diagrams together to make something really cool. So I have my window fan. These fans, what what my plan is to stack them up one another, and I'm gonna get another like 3 or 4 fans maybe, and I was going to use just some chicken wire to loop them together, but I think I might screw them onto a metal plate that runs across. But that's not the point here. The point is these electronics. All right, so that was a lot of fun. I hope you guys learned a lot. I did have to waver, and I did do some research beforehand. This stuff is tough. So many tutorials go through the sheer basics, and they don't teach you about those extra pieces. So if you enjoyed this video, please, please, please give me a thumbs up, like the video, subscribe. If not, do give me suggestions. Leave a comment below. Tell me what you want to see, because I'm always building stuff. I'm always looking to expand my skills, play around, fiddle with new things. And I'm just going to turn this back up a bit. So, see you next time. Thanks a lot, guys.